Hello friends and welcome to my channel. In this video I will modify this circuit for solar hot water to be off-grid. Now I will show you the exterior. You can see the vacuum tubes for hot water, and nearby there is a solar photovoltaic panel who gives me current. Now I will show this is the initial installation. Now you can see this is the temperature in the boiler, and this is the temperature in the solar panel, in the vacuum tubes. As you can see, there is some difference. I choose this it's afternoon because I cannot take this off the main when the sun is very powerful. Now you can see temperature increase very slow. In the middle of the day, temperature increase very fast. Now this controller it's powered from this socket. I will modify this circuit and I will power this controller from my photovoltaic panel, and this is the input voltage from main power supply. This is the output. This is connected to the pump that circulate the water in the circuit, and these wires are from the sensor. I have a sensor on the boiler. Now it's on the boiler, and now it's the sensor from the hot tubes with vacuum. And I will modify this the power for this controller will be from 12 volts, and the supply for this for the pump I will make with a sine wave inverter from my battery, who is charged with a solar panel. Now I will present the inverter that I'm using. This is the sine wave inverter. I already tested with oscilloscope and it's really sine wave. It has a continuous power to 200 watts and peak power 400 watts. I use pump, it's only 30 watts power, so this is enough for me. This is the inside. It's well made. I will use this socket for output, and I mounted this will be used for remote power. when I apply this 12 volts, this 12 volts is equivalent to power up and down. When I put here 12 volts, it's similar to remote power on. When I take off the 12 volts from here, then this inverter will power off. This is the best solution for power on and off, because this, on the input, there are very high currents. And if I use the switch here on the great power, it's possible, but it's not reliable. If I use a relay, in time this relay will destroy. But in this configuration with this remote power on and off, I hope this will last a long time. Now let's go to the next. As you can hear the alarms, here in my neighborhood the power is down. That's the main reason why I decided to make this hot water installation off-grid. And for testing, I put this UPS battery, this sine Y inverter, this adapter, and controller and pump. Just a few seconds ago I tested, and this solar panel temperature is decreasing, and that means that water pump is working perfectly with this sine wave. Now that's a final test, and I will continue. Here is the controller. This controller enters two thermistors, one from solar panel and one from boiler. When the difference between them is bigger than 25 degrees, then this controller starts the pump to equalize the temperature. Now I took this apart to see what's inside. Now I have to modify this to work on 12 volts. Now it's on the main power supply. Let's start. As you can see, now there are not thermistors, and it's some kind of error. But I just want to measure the voltage. Here you can see this transformer. This transformer has two outputs. This is the primary winding, and this is the secondary winding of the transformer. Now let's measure the voltages. We'll start on alternative voltage. 13 volts first winding and 13 volts other winding. Now let's measure the voltages after rectifier. We'll use this ground. We have plus 15 volts and minus 17 volts. I think that's this difference is because on the positive side there are more loads, and because of that it's a big current consumption, and that's why the voltage is lower on positive side. Now let's take this mains cable off. I will use this module I bought from China. Here is in. Here on input you can put 12 volts, and here on output we can take plus minus voltage, and here we have adjust. I will adjust this to 16 volts to be the same like the requirements of the controller. Hello friends, that's 5 a.m. in the morning. I hope that you can hear the sounds. And I wake up this early because I have to make all these changes until 10 o'clock when will be hot, and I need all this be functional. Yesterday evening I cannot finish the job because the power was down again. Now I made the changes to the PCB. You can see I put this output. This black wire it's ground, red wire it's plus, and this yellow it's minus. I write this on the case, and now I will put everything together. First let's make a test, and after that I will put together. Another stage is over. As you can see, I mounted this controller back. I put this green wire, it's the output for remote power of the inverter. The up wires are the sensors. They are working good. This is the panel, and this is the boiler temperature. And these are the wires, green, minus, plus, and ground. I put this module, and for the moment I put this battery for UPS until I will have the 12 volts here. Now that's 7 o'clock, you can see the sun is rising, and I've completed another stage. I mounted this inverter with this protection plate. These are the wires. This is my battery. Now let's check. Now it's off. Let's turn on. It seems it's working. This is the remote. This I will connect the remote wire. I prepared this cable and this protection for cable, and now I will begin the next stage. Now that's almost 9 o'clock and another stage is over. Here you can see the pump. Pump has 3 positions: minimum, medium and maximum. Now it's on minimum power. That's 30 watts. Here is the cable through this protection. And here is the socket. This is an universal socket. Now I will connect to the inverter and I will make the first test. It's connected. Yet it's not a remote wire, it's not connected yet. And I will manually start the inverter and the pump. I hope that you can hear the pump. It's starting. Let's get to the pump. The pump is working good. Now that's 11 o'clock, I finally put everything together. Here is 12 volts from solar panel, from battery. This is output plus minus 12 volts. And this is the controller. This is the output. It's the command for remote to start the inverter. Now let's see. Now it reached the threshold. And now the temperature is decreasing. That means that everything works perfect. Now we are seeing the temperature from the panel. This is boiler, this is panel. Now I have to make a box, a fine case for this module, and I will put somewhere here. And after that I will make a photo. Now I want to present you the block diagram of my work. Here the central part is the battery. You saw my battery is 12 volts, 100 amps hour. This one is the inverter. Input is 12 volts and output is 230 volts, and it's connected directly to the pump. This is the remote power on off. When we have here 12 volts. Inverter start working. When put this to the ground, inverter stops. This one is the boost module, and from 12 volts from the battery makes plus minus 15 volts. We apply this voltage to the solar controller. This solar controller has these two thermistors, one to the panel and one to the boiler. When the difference between them is 25 degrees, then controller gives here a plus 12 volts signal. This plus signal turn on the pump. When the pump is working 10 seconds, then the difference between this temperature decrease, and this output goes to ground, and then pump is stopping. Now I want to present you my first impression after first day of use of this installation. I have to say that it worked okay as I expected, but there is a small problem. You saw this module. I put 12 volts in and takes out plus minus 15 volts for the controller, and I noticed that this module is very hot. These coils are very hot, some 60 degrees Celsius, and this I see. First of all, I thought that it's a very big consumption, but I made this test. I put this module with the controller on my power supply, and the power consumption was under 2 watts. Then I put a module like this with 2 load resistors to emulate the controller, the load, and I put 12 volts here, and calculate this to have same amount of power consumption of this module and the load together like the controller. And I noticed with 2 watts power consumption and load here, this module gets very hot. Even the producer says that this works up to 20 watts. Now for the moment it's working, but I am concerned about this module not get broken, and that's why I decided to make a new version of this one, and instead of these coils I will put a classical SMPS transformer, and soon I will start this project. If you have any questions, please put it in the comment. If you want to do this, or if you did something like this, please put it in a comment. I hope that you find this helpful. Please like and subscribe. Thanks for watching. Bye.